We have just understood double angle formulae in our previous video, and we have been able to show that sine 2a is equals to sine a cos a. We have been able to show that tan 2a is 2 tan a over 1 minus tan squared a. And we have also been able to show that the cosine of 2a is cosine squared a minus sine squared a, which is also equals to 2 cosine squared a minus 1, which is also equals to 1 minus 2 sine squared of a. And under example 7, we are supposed to prove this using this knowledge now. Show that, or we are expected to say, use the double angle formulae to write each of the following as a single trigonometric ratio. If you look at part A, obviously it is in this format. And we are talking about cosine squared of 50 minus sine squared of 50, which should actually be the cosine of 2 multiplied by 50, because our A is 50. So without any further ado, we know that the cosine squared of 50 minus the sine squared of 50 is easily the cosine of 2a, which is the cosine of 100 degrees. And that is just that. Look at part B. Part B, we have been given 2 tan pi over 6 over 1 minus tan squared pi over 6. We have been given this one in this format already. So our A is pi over 6. So what does that mean? This is equals to the tangent of 2A. What is the tangent of 2A? This is equals to the tangent of 2. Our A is pi over 6. And basically, this is the tangent of pi over 3. And that is just what we need to show. The tangent of pi over 3. But if you look at part C, rather, this is part C, we're supposed to show that 4 sine 70 degrees over sec 70. How do we express this one as a single trigonometric ratio? And we have worked with sec 70 before, and this is, we can rewrite this one as 4 sine 70 divided by sec of 70, which means divide by 1 over the cosine of 70. Divide by 1 over the cosine of 70 degrees. If you divide by a fraction, this is the same as saying 4 sine 70 degrees. You multiply by the reciprocal, which is the cosine of 70 degrees. And having had that, having outlined it that way, we can now compare this with the first statement, 2 sine a cos a. Of course, we have sine a cos a. We have sine 70 cos 70. But instead of 2, we are having 4. So how do we make this 2? Of course, if you factor out the 2, open bracket, we are going to have 2 sine 70 cosine 70 degrees. And this one is perfectly looking like that. And what is this part now? This is supposed to be 2. The cosine of is supposed to be 2 multiplied by the cosine of 2a. Not the cosine, but the sine. This is 2 sine 70 cosine 70, which should be compared with 2 sine a cos a to mean sine 2a. So this part is simply sine 2 times 70, because our a is 70, which is 2 sine 140 decrease. And having had that, this is basically how we can outline it as a single trigonometric ratio. This is how we have outlined this one as a single trigonometric ratios, and this is how we have outlined the first one as a single trigonometric ratio. Remember, we had to borrow heavily from what we have understood in the previous video. Okay?